Hello, today we are going to design a rooftop solar system with PVsol software, PVsol Premium version 7.5. I'm Shayan Razaghy and I will be the instructor of this course. Okay, and we go. So start our course from this part of the software. As you see here, we have the actual visual interface and of the software. Here is the first scene actually you come up when you open the software, and it has different tabs here, different buttons here. This is the first part, as you see, the welcome part, and the next part is actually the tab that is established for the project data. Here we can set the project data. It helps us actually for later projects. We can come back to these projects easier. We can search for them easier. And another important factor is that if we enter proper data here and completely all the fields are actually filled completely, then we can expect the software to develop a report for us that actually includes a great cover letter, and on the letter of that product, the cover of that actually report, there is a great cover letter for us full of information. So here we can just write down some of our project data. For example, the project number, just imagine it would be PR008, project designer me, for example. The customer number would be C004. Contact person is, for instance, Mr. James. Oh, sorry. Yeah. Company, phone, fax, email, address. Start of operation. When will the plant will start to operate? What is the project name? Let's call it a test project in our class. If we have any images from the project, actually the project is not developed yet, so we can have just some images from the roof maybe, or from the from the ground that we want to install our ground mounted structures. So we go to the next tab here. From now on, we have started the project for more details. Actually, the previous part was just about something not that much important in yield assessment. I mean, the data entered in the previous part doesn't affect the yield, the plant yield, the plant energy yield, annual yield, I mean. For the first part, we should determine the climate data. In which country and which location will our project be located? But as you know, maybe this database of the software not be very actually complete, because there might be some places that are not included in the database. For example, let me use United States. Okay, we have many cities here. For instance, in Los Angeles, the international airport is included in the database. But what if I want to install a solar plant somewhere else, not exactly in the international airport? For example, in my own house, or maybe somewhere in Beverly Hills, so who knows. So what shall I do? Here I can choose this globe actually icon. The software starts searching for map data, and then so the map is loaded now, and we can start again searching. Oh, sorry, United States here, and the state actually, let's go to California for example. Just imagine we have different locations here. So if we want to choose from the predefined locations, we can use this part. But as I told you, if we want to generate and create more climate data, because the plant location is not actually included in the database of the software, we should press this button called create climate data for new location. So when we click, we'll again have another map here. We should go back to United States. Then by scrolling up and down, we can easily zoom in and out. So here's Los Angeles. So let's zoom in. Let's get inside the city. So just imagine here I want to install a solar plant on my roof. So I right click, new location. I can call it a name. The state and zip code, if we know, we can enter it, but at the moment it's not needed. Okay, so we click on OK, and after a while the software starts making and creating new climate data from the MeteoScene software. Actually, MeteoScene or let's say MeteoSign is a built-in software in PVsol, and all the climate data is entered from MeteoScene. So as you see here, another location, a new location, as we called it, my plant at class, is already added to the database. When I click OK, so here now is my new location where I can easily start designing my solar plant. But as you know, this part is of great importance because the climate data directly affects the total annual yield of the solar plant, and it's very important in the actually other sections that we want to design the system. What about the software? Let me tell you that in this course we are just going to have a short introduction of designing a system with this software, because this software is a great one and it requires let's say a several-hour course for designing a system with the whole details and using and expressing all the capabilities and abilities of the software. So here we're just going to design a system, a rooftop system, with not much details because we have not enough time for that, and we are just going to have a short course now. For more details, you can refer to the advanced courses of designing with PVsol software. So if we want to use the 3D design ability of the software, which is the most important feature of this software, we should click this tick as you see here, and type of system. Is it a full feed-in? Is it a net metering, or is it a net metering with battery system? Just imagine our system is full feed-in. I don't want to go through the differences between these systems. As you know, full feed-in, it means that the whole yield is actually injected into the grid. In net metering, we have a bidirectional meter, and net metering with battery system, we have some chargers that during the day when we have solar irradiance, when our solar plant is functioning, we can charge our battery system and at night we can discharge the batteries and feed our appliances. So just imagine we have a full feed-in system. We go to the next tab now. Oh, sorry. Let me tell you one other part. That is the AC mains. This actually part is about the grid settings. Our grid, as you know, in United States is 120 volts AC, and we have a 3-phase system. Displacement power factor is 1 minus or plus. And another parameter, this is about specific CO2 saving through the use of PV energy, 600 grams per kilowatt hour. It means that if we install a solar system, and just imagine it generates 1 kilowatt hour of energy. This energy, if we wanted to produce and generate this energy with fossil fuels, then 600 grams of CO2 would be emitted into the atmosphere. So this is the parameter. It means that by generating each kilowatt hour of energy using renewable energy and PV energy, photovoltaic, we avoid emission of 600 grams of CO2 in the atmosphere. That's a great solution for preventing the climate change. So, and we go to the next tab in the 3D visualization and 3D design of the software. When we want to start it, we should start with edit button, then the program is and the software brings us to another window just after a while. Okay, so we are redirected to this page. As you see here, we should specify that on which sort of structure, let's say, our system is going to be built on. Are we using and are we installing our solar plant on roofs, on complex buildings, a building with a flat roof, for example, a building with pitched roof, tented roof, hipped roof, half hip roof, and other type of roofs? Or are we going to install our system ground mounted on an open area? Just imagine we have a roof and it's something like this, a pitched roof. We have already defined the location, the latitude, the longitude. The software actually as per our location that we defined, the software tells us the latitude and the longitude. And also we could, if we knew, we could tell the software the latitude and the longitude, the geographical coordinates, and then the software would generate climate data for us. So by clicking start here, this is the roof and the building that we want to install our solar plants on. Let's first look at this building from different views. This is the north view. It means that we, as the observer, we are in the north and we are looking toward the south. So this axis is the south, just we are looking at. So this is the north view. This is the west view, where as the observer we are in west and we are looking at east. Overhead view or south view. South view would be the best one for us because as we are in the northern hemisphere of the planet Earth, the solar panels, the solar modules should be orienting south. So, and the azimuth, it should be towards south. Okay, as you know these things, I'm just not going so deep through these things, and we are just expressing about the software. So if we have any obstacles such as a tree, such as a chimney or something like this, a wall for example, or whatever that can be shading on our solar modules, we should define it, we should set it. So for example, just let me delete this wall, delete this smokestack, which is so big, let's say. Just imagine we have a tree here. I double click on it. We can define the height, the diameter, just see, we can change it easily. Diameter, the center of the gravity, the diameter of the tree trunk, the tree's height, and the position. The position is very important, of great importance. Here's the 0 point. X is 0, Y is 0. So if the tree is 5 meters, let me say 5 meters and 6 meters far from the center, we should enter these positions for the tree. Okay, and about the roof, we click on it and we can change the length of the eaves, the roof pitch. What's the roof pitch? Is it 20 degrees or is it 10 degrees? It's very important. The distance, eaves ridge, the height of the eaves, and the orientation. Is the building orienting south exactly? What's the orientation of this building? Just imagine it is orienting south, so the orientation is 180 degrees. This is the simple mode. If we want, we can change to complex mode, which it has several other parameters as well. So this is our building. Just in this way, the tree will never shade on our solar panels. So let's decrease the height. It's about, let's say, 4 meters. Is it enough? The distance, if the ridge is too high. Oh no, I meant 15. not 51. Okay, this is the roof. So here's the object view. Here's the object that we want to install our solar panels on. If there are anything like chimneys or vents, if there are, let's say, any maintenance passes, any edges, let me bring this edge, click on this edge. If we want to direct it to this page, as you see here, we should specify that on which sort of actually structure, let's say, our system is going to be built on. Are we using and are we installing our solar plant on roofs, on complex buildings, a building with a flat roof, for example, a building with pitched roof, tented roof, hipped roof, half hip roof, and other type of actual roofs? Or are we going to install our system ground mounted on an open area? Just imagine we have a roof and it's something like this, a pitched roof. We have already defined the location, the latitude, the longitude. The software actually as per our location that we defined, the software tells us the latitude and the longitude. And also we could, if we knew, we could tell the software the latitude and the longitude, the geographical coordinates, and then the software would generate climate data for us. So by clicking start here, this is the roof and the building that we want to install our solar plants on. Let's first look at this building from different views. This is the north view. It means that we, as the observer, we are in the north and we are looking toward the south. So this axis is the south, just we're looking at. So this is the north view. This is the west view, where as the observer we are in west and we are looking at east. Overhead view or south view. South view would be the best one for us because as we are in the northern hemisphere of the planet Earth, the solar panels, the solar modules should be orienting south. So, and the azimuth, it should be towards south. Okay, as you know these things, I'm just not going so deep through these things, and we are just expressing about the software. So if we have any obstacles such as a tree, such as a chimney or something like this, a wall for example, or whatever that can be shading on our solar modules, we should define it, we should set it. So for example, just let me delete this wall, delete this smokestack, which is so big, let's say. Just imagine we have a tree here. I double click on it. We can define the height, the diameter, just see, we can change it easily. Diameter, the center of the gravity, the diameter of the tree trunk, the tree's height, and the position. The position is very important, of great importance. Here's the 0 point. X is 0, Y is 0. So if the tree is 5 meters, let me say 5 meters and 6 meters far from the center, we should enter these positions for the tree. Okay, and about the roof, we click on it and we can change the length of the eaves, the roof pitch. What's the roof pitch? Is it 20 degrees or is it 10 degrees? It's very important. The distance eaves ridge, the height of the eaves, and the orientation. Is the building orienting south exactly? What's the orientation of this building? Just imagine it is orienting south, so the orientation is 180 degrees. This is the simple mode. If we want, we can change the complex mode, which it has several other parameters as well. So this is our building. Just in this way, the tree will never shade on our solar panels. So let's decrease the height. It's about, let's say, 4 meters. Is it enough? The distance if the ridge is too high. Oh no, I meant 15, not 51. Okay, this is the roof. So here's the object view. Here's the object that we want to install our solar panels on. If there are anything like chimneys or vents, if there are, let's say, any maintenance passes, any edges, let me bring this edge, click on this edge. If you want to have some edge for safety reasons, for example, from left, right, bottom and top, for example 1 meter from each side, we never want to install panels on them. Why? Because of safety. Or maybe we have a parabolic antenna, some walls here, or whatever, like a wall, a single saw maybe here. Yeah, this can be. We have another one here. This is the waterproof. By double clicking on it, again we can determine the characteristic of it, that what's the roof pitch, what's the, let me say, the length of it. It's, for example, 5 meters, or is it 2 meters? It differs, yeah. And the position. Just imagine you know that this sawtooth is 4 meters away from the building wall. I mean that this is 4 meters. How do I say that this is 4 meters? Because the the 0 point is here, and the actually the, let me say, the building is on 0 point, so this is the 0 axis. Another way I will tell you later about how we can do it. And it is about 10 meters away from the front part of the building. Okay, I know that. Another way could be right clicking on this object, enter distances. Okay, this is the better way. So I told you that I know the distance from the mounting surface, the building, is 4 meters. So this distance is 4 meters. So I click here, 4 meters, yes. And when I click here, this distance, as I measured before in my site visit, it's 10 meters. So that is the way, okay. And about this object, I don't know where it is. I don't know the distance from this point to this point. I don't know it. I just know that this object is 10 meters, for example, far from this object. From this point to this point is 10 meters. Okay, So right click on it, enter distances. The object is south of roof 2. Okay, this distance, yes, I want to measure this one. This is 10 meters. Okay, so it's very near. Let me say not 10 meters, 8 meters is enough. And what's the distance from the back side of these two objects? Okay, for example, it's 0. It means that they are in the same axis. Okay, very good. Just forget about this actually wall. We don't need it because it's exactly like the other ones. And just imagine we have a window here. Yeah, the window is something like this. Let's double click on it. What's the width? Oh, 1 meter. And what's the height? 2 meters. Where is the position? Do we know it? No. I just know that this window is here, and the distance from here to the building front side is about, so I click enter distances. The distance from the window to the mounting surface, the building, is in Y. I mean, look at this arrow. It means, let me say it's 4 meters. And from the X axis in X direction, what is this? How much is it? Did you measure it? Yes, I measured it. It was about 5 meters. Okay, so here's the window. I found the position. Okay, very good. So now we're going to cover our roof with modules. How do we want to do it? Okay, we have different methods. The first one is module coverage. It means that we don't know what's the tilt angle of our system, or we don't have any specific module mounting system. We just want to cover the roof with our modules. It's for the times that we don't have any sort of mounting system which increases the tilt angle of the system. Okay, just imagine now I want to use the module coverage. I choose a module first from the database of the system. Just imagine I use a 200 watts. It's just an example solar panel. I use it. Okay, I choose it. Actually, I have different methods here. Create module array. I have 3 different methods for putting and installing my panels. One of them is drag and drop. So easily drag and drop. But is it a good way, do you think? No, exactly. It's not a great method. Why? Because if I want to start dragging and dropping, it would take hours just to design a very small solar rooftop plant. So it's not a great way. I select all of them and delete them. So I go to the next method. This is the fill area. In fill area, as you see here, first we should define the module distances, the horizontal and vertical distances of the modules. Is it 1 centimeter? Is it enough, you think? No, at least put it about 3 to 5 centimeters. It would be better. Okay, so the fill area mode is active now. Which area do you want to fill? Just select it for me. Click. Okay, easily. That's the way. Do you want to place active module array? Okay, yes, I want to do it. So this is the way. This is the way that we can easily fill one area with solar panels. But again, I don't think it's a great method. Why? Why do you think is that so? Yeah, as you know, we have better options that can actually install our roofs. Let me delete it. Okay. We have another method which is cover. In cover mode, you may not, oh yes, it's something like this. You don't need to specify an area. The software starts putting solar modules wherever possible. What does it mean, wherever possible? It means that places that are not filled with any obstacles, windows. Okay, that's another way. But is it also a good way? I again don't think so. This is not a great way. Why? Because as you see here, when we move to this part, shade frequency, and click on it, it starts simulating the shades. Oh, as you see, these panels which are in different color, they may face some shades sometimes. These ones, for example. So what would you do if you wanted to install 10 kilowatt system? Surely we wouldn't use these spaces for our solar modules. We would prefer to install our panels in these areas. So the first step would be covering the area and then calculating the shades. Wherever there are shades, if possible, try to avoid putting solar panels there. So I will now select all. I know that if I want to install solar panels, let me look at it again. This row, this part, and this row, they are perfect. The 4 rows here, except these parts actually. Yeah. As you know, these parts, the shade is for that tree that I put it right here, over here. Let me go back to the train view. As you see here, we had a tree, and now we have a great view of our system. Whenever you want, you can click on the scroll button and different views. Let me see, this is the southeast view. Yeah, so these 4 rows were great except these panels. Go back to our object view. Let's select them in module coverage mode and delete them. So what shall we do next? We can use fill area. As we remember, this area was good. How many modules do we have here? 34. It means that 6.8. And I want to install about 10 kilowatts. This part was about also great. So I should again select fill area. Again, I can put solar panels here. Let's fill area, yes. This row was about, again, good places. Okay, now how many? 67. It means that 13 kilowatts. Okay, I just need 10 kilowatts. What shall I do next? I sort the shade frequency calculation again. I can omit 3 kilowatts, but which ones? Oh, let me look. Yeah, this one, these ones, these are not the best places for solar panels. So let's right click on it and remove it. Okay, right click on it and remove it. These three as well, remove them. Remove it. This one also. So how many do we have now? Oh, 12 kilowatts. I just need 10 kilowatts, so it means that I should emit 10 modules. Which 10 would you choose? First of all, these two. Yes, I would remove them, surely. 1, 2, 3, 5, and 10 we have here. So what would you do? Would you emit these two, or what would you emit these 10? You would emit a row. I think this one would be a better opportunity because we can emit a row. As you see, these parts we have shadings, so this one is also, this row is not a perfect one also. So let's do it now with drag and drop. First of all, we can move these panels a bit higher. You want to know why? Yeah, here's the reason. Because I want to place the other two modules right here. And I want to omit these 10. Let's select all. Okay, I have 50 modules and 10 kilowatts. So, is my designing perfect now? What are the faults? The first one is these modules, they are not in same axis with this one, and it's very near. So right click on it, separate selection, and we should move them and put them in same axis with this one. Okay, now it's better. We can also do all of them with using the method I told you in selecting and entering the distances. So this is a perfect, rather perfect, let's say. And in module mounting system, we can again do the same thing, but in this part, if we want to have mounting systems for ground mounted systems, we would use this part. As I told you, in advanced courses, we can go through these tabs as well. Then we should configure our PV system using inverters. So we use this part, then we should choose an inverter or ask the software to find the best suitable inverter for us. We want to select an inverter manually. We need one inverter with, in examples, we have not a 10 kilowatt. So I choose another inverter, and something like this one maybe would be great. Yeah, we have one of these ones, and we have 50 panels. We should first know the datasheet of this inverter. So we should select the inverter data and start it. So the software didn't find any suitable inverter, so we should do it manually. So let's select the inverter, go to this part. Here we can see the datasheet. As you see, the AC power rating is 10 kilowatts, nominal DC voltage is 379, minimum MPPT voltage is 300, maximum is 480. So in regards to our solar module, we should design the number of modules that can be in a row and in a string, in series I mean. As you see here, we have some guidelines. Minimum number of modules in row 14. Minimum number of modules for T. At the moment we have 50 modules that are not configured. So in MPP1 we can have, let's say, 3 strings with 15 modules, or because we have 50 modules, we can put them in 5 strings of each one 10 modules. Can we do this, do you think? No. Here's a cross. It means no. And what is the reason? The reason is, as you know, here's minimum number of modules in a row or in a string should be 14. So can I put 20 strings modules in a string? Can I do this? No, again. And with 3 strings, again we have some fault here, as you know, and we cannot continue because in this way we are configuring 60 modules but we only have 50 modules. So what can we do now? It means that we may not find a great configuration with this inverter, so let's change it to another one. It also has 1 MPPT. We're searching for a module or an inverter with more than 1 MPPT, something like this. So we have 2 MPPTs here. I would choose 3 with 14. It means that 42 and 1 with 8 modules. Is it possible again? No. So I would choose, let's say, 2 strings with 18 modules. It seems that 36 and 1 with 14. Again, is it great? Let me check the system. Oh, here the sizing factor is not great. As you know, it's not in the design range, which is between 90% and 110%, but we can continue our configuration. Okay, this is the configuration. This is MPP tracker 1. Double click on it. We have 2 strings, string 1 with 18 modules, string 2 with the 18 modules, and MPP tracker 2 is string 1 with 14 modules here. We can set the direction and starting point and course of the actual configuration. It means that if we change it, look at here, direction to vertical, we can change the configuration, and for example we can put these panels in 1 string or these panels in 1 string. It's we can use it from this part. Okay, now when we exit, the software asks us whether we should adopt data in PVsol. We click yes, and by clicking yes again, the simulation is done again, the shading simulation I mean. Okay, this is a simple view of our system. In next part we are going to the cabling. We can just start it and design it in details, or if we want to just tell the system the total loss, for example, we tell the system that assume 1% loss for cabling of the system. Next, we have a circuit diagram. As I told you, because we just want to have a short course, we are not going so deep. In advanced lessons, we can have more details about this verse. Here we have a circuit diagram, a single line diagram, SLD, let's say. And next part is financial analysis, which is not included in our session and in our course today. And the last part is the results. So here is the final tab of the system and the results. As you see, the production forecast is here in different months. We will have different productions. For instance, in July we will have about 1070 kilowatt hours energy yield in 1 month. And if we right click on it and using copy, just let me open an Excel to see what will happen and paste it. This will be the results. But if I right click and copy table to clipboard, we can have all the data here in a table and paste it again. Yes, as you see, we can have all the results in numbers in tables. And the last part is the report, the presentation of the report. We can export it to Word and PDF formats both. When I export the report here, just after a few seconds again, we can save it somewhere. I just save it in my desktop. So here is the report. As I told you, if we have enough information here, so here's the report. As I told you, if we have enough information here, we would have a great cover here. So I scroll through the next parts. Here we will have a brief photo of and the general view of the system. Usually it's the south view. This is our system characteristic. Actually, it's 10 kilowatt power system. The PV generator surface is about 84 square meters. We have 50 modules and 1 inverter. This is the single line of the single line diagram. And we will have the total yield. This is the most important, let's say, factor that the software simulates for us. And we will have the specific annual yield, which is a great important factor for installers, for designers, for financiers, and for investors. It's about 1,500 kilowatt hours per kilowatt peak. The performance ratio is 80%, and some other factors as you see here. Just we go through it. Again, we have another view of the system, and then we have the losses. Then there's the production forecast of each month. And this is a great part which we have detailed selection and detailed data about the energy balance. The first part is the radiation, global radiation, first horizontal, then it's in inclination, we have more, and then the radiation at the modules when we multiply it by the actually collector surface, we will have the global PV radiation. Then due to the rated efficiency of modules, we will have some part of it available, soiling and other losses. All the losses are listed here, and this is a great data as I told you. And the last part is the grid feeding. The whole energy that will be fed into the grid is this one in 1 year. Then we go through the financial analysis, which we didn't speak about in this course. As I told you, we will go through it in advanced courses. These are about financial analysis. Here's a brief of our solar module datasheet. Next page is a brief of our solar inverter datasheet, the technical data, the characteristics, the features, and the last part is the single line diagram as we had it before in a more detailed and bigger size here. So by this part, our short course about designing a project with PVsol software, a rooftop project, is done here. I'm Shayan Razaghy, and I will be so glad to be in contact with you for any further questions if you had. Feel free to contact me, and have a good time. Bye bye, take care.